going to have a later portion of the talk to be open mic. So I have an iPad here with a bunch of questions that you guys are submitting. We'll go through some of those top voted questions. But as you guys are going to fill those out, I want to quickly ask folks, how many people here use AI to write their code? Just a quick raise of hands. Okay, good amount of people. Keep your hands up though if 100% of your code is written by AI. Let's look around the room. How many people is that? Okay, it's a lot more than before when I asked these questions. So it's really kind of an interesting time to be here talking about this stuff because all of us are witnessing this transformation in our industry. And so I think we're going to get this question started. I'm going to have a few questions that I'm going to start off first. And then as you guys fill this out and vote on the top questions, I'll get to those afterwards. So just a few quick warm-up questions for us. How many lines of code have you written this year?
How many lines of code?
Yeah.
So I pulled the answer for this in prep because I knew you were going to ask that question.
Yeah.
Okay. So 1.7 thousand PRs, added 400,000 lines, deleted 250,000 lines. So
okay.
I think last year it was actually I deleted more than I added. But this year I added a little bit more than I deleted. And I also tried to get the token count. Unfortunately, the data kind of gets deleted due to retention and stuff. But since March, I used 8 billion tokens.
8 billion tokens. And so those lines of code that you deleted and added, those are all written by you or Cloud Code?
100% of my code has been written by Cloud Code since Opus 4.5. So that's like November of last year.
That's crazy. And then do you use your phone or your laptop? Like, what's the split nowadays when you code?
Yeah, this is sort of like the craziest thing. Like, I would not have predicted this if you asked me like 6 months ago, where are we going to be doing our coding? But yeah, like most of my coding now is on my phone. I would have said you're crazy if you told me that 6 months ago. Customers and kind of future customers. And broadly, people think about it in 2 ways. Some companies think about it in terms of the cost. And other companies think about it in terms of ROI. And I'm like, ROI is absolutely the right framing because you don't want to just think about cost because you kind of spend something on it and you get something back. When you think about ROI and kind of like deploying Claude Code in general, I think it's useful to think about like what's a really good way to deploy it. And I think like the most successful companies we've seen, they sort of give everyone tokens, not just the engineers, but also like the product managers, the designers, the data scientists. They give everyone tokens and let the company experiment to see where the ideas come from. Because often it's just like not the person that you would expect. Often some of the most interesting ideas and the most innovative like ways to improve processes and kind of like new product ideas, it's gonna come from like, you know, like an accountant somewhere in the corner of the org or like a marketing person that you've never heard, that the CEO has never heard of. That's where a lot of the innovation comes from. It won't necessarily be like the most senior engineer always. And so I think for this reason, like you kind of want companies to experiment, and you want your team to experiment. The way to do this is give people tokens and give them safety to experiment, so they feel like they can try stuff and they're not going to get kind of penalized for it. Once you find these internal use cases that kind of work, then you want to control the costs, and you want to do that on the back end, not on the front end. And you know, like once there's some use case that takes off, uses a lot of tokens, then you want to think about how to like optimize that. There's all sorts of ways, like, you know, like in Claude Code, we have like per seat cost controls. There's ways to use like advisor models. You can change the model for your entire company. You can control the effort level for your entire company. You can set budgets like based on department, based on RBAC. So there's just like all sorts of ways to do this. I think that maybe like the second way to think about it, so this is kind of like the deployment side and like how to actually get it out and like when you're like at the very beginning. Once companies have been using Claude Code for a while, you really do want to think about ROI. And you know, like for ROI, there's kind of like 2 parts. There's the investment and there's the return. In the past, the way that, you know, investment is easy to measure. That's just tokens. Return, in the past, the way that we used to measure it is what % of the code is written by AI, or maybe like % increase in the lines of code or something. And yeah, like, you know, we just saw a bunch of hands go up that said, you know, like 100% of your code is AI. So once it gets to 100%, how do you actually like measure that return? And that's where it gets kind of hard because, you know, like we worked on dev infra back in the day. And, you know, like on dev infra, you know, like if you have like a percentage, like 2-3% productivity improvement for a year, that used to be like pretty good. Now the productivity improvements we're looking at are, like hundreds of percentage points. And at Anthropic, we've seen like a 8x increase in code per engineer since the beginning of this year. And so like in this kind of regime, how do you think about the return? And so I think part of it is get to 100% of your code written by Claude. Then think about how much is the code per engineer accelerating? And then the third thing to think about is like, what are the other bottlenecks that are getting in the way? Because once you get it to this point where engineers are just like writing a lot of code, the bottleneck is going to be like good ideas. So how do you kind of unhobble that so that your company can generate ideas faster? And this could mean like more PMs or user researchers or something. Then you have to think about how to get these ideas to market faster. So this is kind of unhobbling on the GTM and on the marketing side. So this is kind of roughly the order that I think about it in. And when I look at our customers, everyone is...
It's actually from our ex-colleague, old colleague, Peter. He asked, like, is loops the next hype cycle or is it real? Maybe you can explain what loops are for maybe people who aren't familiar with it and then how you use it personally.
Yeah. Have people here tried loops, routines?
Still pretty nascent, yeah. Not
okay, and just so I know like how technical to make the explanation, raise your hand if you're like an engineer that codes. Okay, so I think like for the engineers in the room, the way to think about it is 2 years ago, we wrote source code by hand. We started to transition to make it so agents write the code. And now we're transitioning to the point where agents are prompting agents that then write the code. Or maybe that's like the less technical explanation. The more technical explanation, like actually my mental model is sort of like if like source code is like kind of like the basic level, that's sort of like a statement in programming, then the agent writing the code is like a function in programming, and then loops are like a higher order function. So it's sort of like we're stepping up the abstraction ladder. It's one more step.
Yeah.
So loops are sort of like as big as the step from source code to agents was, loops are the step from agents to the next thing. It's just as important and as big a step. To me, it feels like right now in the world of like loops where, I don't know, like maybe where agents were like a year and a half ago. So it's still like fairly early, but we're starting to see signs that it's working. And the idea is like, okay, let's say as an engineer, a lot of my work is to do code review. And so like one thing that I could do is like, I could do the code review by hand. The other thing that I could do is I can have an agent and I can prompt my agent to do the code review. The loop version of this is I have an agent that's running in a loop that does all of the code reviews. Or like another example is, like I read threads to see like people's feedback. And so like I could do this by hand, or I can have an agent do it, or I can have an agent that's constantly looping over and every like 5 or 10 minutes reading the feedback and putting up PRs for the fixes. And so like like a year and a half ago, we were kind of at the first step, now we're kind of at the third step. And so like when you think about all the work that we do as engineers and all the work that, like non-engineers do, like designers and data scientists and, like marketing people and so on, a lot of the work, I think we can probably chunk up into loops in this way. And I think we're starting to get to the point in the industry where like a bigger and bigger percentage of the code is like expressed as loops and a bigger percentage of the work. And so for me personally, maybe at this point, like 30% of my code is written by loops on an average day. If I try really hard, I can get to like 100% for some days, but it doesn't totally click yet.
Nice. I feel like if we ask the question of how many engineers write loops, maybe in a year from now, we'll see more hands. So in some ways, you're always like just kind of living the like 3 months, 6 months ahead of the rest of the team here. And so like I think loops.
Whatever you use for collaboration.
Sounds good. The next voted question was, since agents can do most of the code now, where should engineers focus most? Kind of touched on this earlier, but yeah, curious.
Yeah. So, like as we think about like what engineers do, one of the things that we do is coding, but we do like a lot of stuff that's not coding, right? So we do, like talking to customers, coming up with ideas, jamming on stuff with designers and PMs, doing data analysis, figuring out what to build next, aligning with other parts of the org. There's just like all sorts of things that we do as engineers. I think over time, the model will be able to do all of these things better than we can. We're not there yet. And so I think in the meantime, like the model does the coding, but someone has to prompt the model. And figuring out what prompt to give the model there's actually like a lot that goes into that, right? Like you have to kind of figure out what's the next thing. You have to do the market research. You have to talk to your team. You have to do all this other work. So yeah, it's kind of all these other things.
Yeah, and I think, like you said, with loops too, that's also progressively moving up the abstraction layer, where maybe at some point, for some certain cases, you don't even actually need a prompt. And so I think it's interesting, like I said earlier in this conference, is like we're in this like transformational stage. We're all figuring this out together as an industry. We also have seen at Meta that like you said, it's actually a minority of an average software engineer's time is actually spent coding. It's all the other things that kind of happen upstream and downstream with it, whether it's like managing your code deployment or if it's like collaboration and working kind of like in docs and planning. And so I think this is kind of like where like Claude and other apps and products for AI is just thinking about how can we just accelerate the whole development lifecycle. This is something that we're largely solving now with coding, and we're going to continue doing so. But then the upstream and downstream parts of the development lifecycle is still the thing we're discovering.
Yeah, and like coding, I think was always the minority of the time, right?
It's always been, yeah.
And for me, it's like sometimes it's like really fun to code and like write a bunch of code by hand, and then sometimes it's just like a total slog. And like I never wanted to do it by hand in the first place.
Yeah.
I hear an engineer laughing. Yeah. And so like like sometimes like when I don't have Wi-Fi on like an airplane or something, I'll still like write code by hand like just for fun. But it's actually like not something that I personally really miss. It feels to me like Claude Code is just like this like jetpack where like as the model gets better, I get like more jets or something in my jetpack, and I can go faster and faster. And at this point, I'm like purely bottlenecked on how fast I can prompt. And most of my prompting now is actually just like audio, like talking to Claude, and being bottlenecked on good ideas. But coding is just no longer the bottleneck.
Right. And this is kind of like what a lot of conversations have been about. It's like, what is the role of software engineering? It's like less and less about the coding aspect and more about sort of like how you supervise these agents, how you sort of manage the agent end to end, and help generate and productize some of the ideas that you have. I think related to that is like, with the explosion of AI generated code, everyone's just like writing code so quickly now with AI. How do you or Anthropic sort of like handle the downstream impacts of that? So like with code review, right? Like I think a lot of companies require a human code review. That paradigm may or may not be actually breaking or shifting because of the increased supply from upstream. How are you thinking about that?
Yeah. So when we think about code, essentially like you write code and then it gets to production and then hopefully it drives a business metric for you, like revenue or usage or whatever it is that like whatever business metric you care about. When we think about this process, there's all sorts of different bottlenecks, and the biggest bottleneck used to be coding. We've now solved that bottleneck, and at Anthropic and for a lot of our customers that have adopted Claude Code for a bit, they're getting to this point also. And so like now we're thinking about the next bottleneck, and for us the next bottleneck was code review. You write a lot of code, now someone has to review it. And our answer was to build a product for this. And so we built this product. It's called Claude Code Review. It's available to anyone. You can use it. It is the exact same code review product that we use internally at Anthropic for every single pull request. It is different than any other code review product on the market because it's a lot more expensive. And the reason it's a lot more expensive is it uses a large number of tokens to fully automate the code review. So by the time that I see a pull request as an engineer, there's essentially a guarantee that all the bugs have been caught. And it's not, it's not 100%. We're still working on improving it, but it's like, like 98, 99% of the bugs. So like when I look at the code, essentially like I'm not looking for bugs anymore. I know there's no bugs because Claude caught it and Claude fixed it. The next thing is like, is this a pull request that should exist? Is this a good idea? The next bottleneck for us was security review because you're landing all this code. You need it to be secure. Like agents can introduce vulnerabilities the same way that people can. And so how do you make sure the code is really good and secure? And the answer for us is the Claude security product. And again, like we build this internally to solve our own problem, to solve our own bottleneck. And what it does is every week we run it and it scans over all of our code bases, it finds issues, and it fixes them autonomously. And we're actually at the point now where we do red teaming and we do penetration testing for like every big new feature launch to make sure that it's secure. And we're actually getting to the point where Claude security is catching issues that even pen testers didn't catch.
Oh, wow.
This didn't used to be the case. We've had this product for a bit, but because of the model with Opus 4.8, it's now starting to get to that point. And so, like this was the next bottleneck. And so, we solved it. And again, we make this available to a product, so customers can use the same product too. And this is just like the Claude security product. And now we're thinking about the next bottleneck, and the next bottleneck might be like idea generation. It might be like optimizing CI to make it kind of scale better. And so, for example, a thing that I did last night is I noticed that our CI was a little bit slow. And so what I did is I had Claude Code run, and I said, use a workflow to look at my data, look at real CI timings from from the data set, and optimize CI to make it much faster. That was my prompt. That was the entire prompt.
That's it?
That's it. It used a dynamic workflow, which is this new feature that we launched a few weeks ago, where essentially the model kind of orchestrates dozens, hundreds, thousands of subagents dynamically. It's essentially like it's a new form of test time compute. And it used, I think, something like a few million tokens, and it ran for like a few hours. And it produced 4 pull requests that reduced CI time by 50%. And so I landed those last night. Yeah, so it was something that I've been experimenting with is actually using like loops for maintenance.
Loops for maintenance. Can you share more?
Yeah, so one example is you can have Claude Code running in a loop to be like look at the code base and improve the architecture, or look at the code base and find places where the test suite is flaky and improve it, so to get rid of the flakes. Or find instances of tests that are not useful that we can just like delete. Or look at the code base, look for duplicated abstractions, and unify it into a single abstraction. And so these are actually like all loops that I have running.
Like in those cases, do you check or review what the code does before they delete or make any changes, or you're just they just send out PRs and you're just like reviewing them after they run the loop?
Yeah, it's the second one. So I just look at the PRs.
You just look at it, the change after they made it.
Exactly. Okay. For prompts like this, it's actually like quite easy, I think, for Claude to kind of wrap its head around these shape problems. So it's usually quite good if you use the latest model. And if the result isn't good, all you have to do is say, look for opportunities to improve the quality of the code base, and then just add the magic words, use a workflow.
I thought you were going to say, make no mistakes. I thought that was
maybe that would work
phrase.
too. But yeah, it's like essentially like just say use a workflow, and it'll throw more test time compute at it, and it'll give you a much better result.
Yeah, that's really cool. Workflows is a pretty new concept. I think I saw an announcement about it. I don't know how many people here are familiar with it, but it seems like another one that we should be watching out for. Like, is there a quick summary of the difference between workflows and loops, or is it kind of like the same thing?
Yeah, it's fairly different. So the way I would think about it is, there's these traditional scaling laws in AI. And there's this like scaling laws paper a while back that kind of introduced this idea that the way that transformers scale and the way that LLMs scale is it's a function of the data, the size of the neural network, and the amount of compute that you use to train the neural network. And so like this is this kind of exponential property of the model. This is why intelligence keeps increasing exponentially, is because of these 3 scaling factors. Over the last couple of years, what's happened is we've actually added a 4th factor, which is test time compute. And essentially what test time compute is actually just a fancy way of saying how many tokens does the model generate. That's it. So there's a way to like make it so the model can productively generate more tokens in order to achieve a better outcome. There's a few ways to do this. One is effort settings. And so, for Claude models, there's like low effort, medium, high, extra high, max. This is a way to configure how many tokens essentially you want the model to output. This is tuning the test time compute behavior. The more tokens, the better the result. The second way to do it, which we just introduced, is dynamic workflows. And this uses Claude to essentially write a little kind of like program that's running actually in a virtual machine to orchestrate other Claudes to solve a problem. It's a new form of test time compute that we're still just exploring, but essentially it's a way for Claude to launch dozens, hundreds, thousands of agents to get work done.
Wild. Awesome. Okay, next question. What are some of the hard problems that Fable has had a hard time to solve?
Yeah, I think that, our models are not perfect, and there's a lot of, places where they still need to improve. One of the places is product sense.
With this last question here. This is a question from Andrew. He asks, how do you prevent engineers from getting lazy and accepting everything they output in Claude?
There's a couple ways to think about it. Um, I think there's like maybe like two parts to this question. I think one part is how do you make sure that the output is really good and that people are kind of doing the right thing? One way we think about this is how do we get Claude to do the right thing so you don't have to? And like an example of this is, like since the beginning, we've had these permission prompts for Claude code. And, like the prompt, like anytime Claude wants to run a command on your computer, it asks you, is it okay to run this, yes or no? Like can I run this bash command? Can I use this MCP? Can I fetch this URL in a browser, yes or no? And an engineer sitting there has to approve it or decline it and say yes or no. And something that we found is over time, it felt like you get kind of like a little lazy. And, at least for me, I just like kept saying yes. I wasn't really reading the commands. And I'm sure this is kind of true for a lot of people. I don't know if like you admit this to your boss, but and so like our security people actually saw this and they were like, hey, like there's a human in the loop. The goal of that human in the loop was to improve security. But actually what's happening is that it is hurting security because people are just like, they have this like prompt fatigue. They just like keep saying yes without actually reading the details. And so the thing that this led us to build is auto mode, which is a new permission mode in Claude Code. This is what we use internally at Anthropic, and actually now like the vast majority of our users use it also. And what this is every permission prompt we route to a model, and the model decides yes or no based on what you've said so far in that conversation. And not only is it more secure, and we've kind of shown that the results are better than dangerous mode and better than the default yes-no permission mode because of prompt fatigue, but it's actually like kind of one less thing I need to do as an engineer. And so the thing that it unblocks is very long-running agents. Because you don't have to sit there saying yes or no, it means I can now run Claude for hours or for days. And there's all sorts of benchmarks that show that like Claude is the best at these kind of long-running tests. And of course, like there's years of research that went into making auto mode working, because like that made it work. Because like if you look at Claude models, they're essentially not resistant to prompt injection anymore. They're not susceptible to prompt injection anymore. And this is a thing that I think surprises people sometimes. But if you look at our system cards, the success rate at 100 attempts is like around 1%. It's just by far the best in the industry. And when you take this and combine it with a prompt injection classifier, which we run for a large share of traffic now, essentially the models are not susceptible to this kind of attack anymore. And what this enables us to do is ship auto mode. And what this means is that as an engineer, I don't have to sit there and say yes or no. So this is, I think, like part one answer to the question, which is let Claude do more and figure out how do you unblock Claude to do more safely rather than trying to control it yourself. I think the second thing is kind of like, what is the feeling day to day as an engineer when you're not writing the code anymore? How do you still learn? How do you still stay in the loop? And actually, one thing that I found really powerful for this is output styles in Claude Code. Whenever any new engineer joins our team, we tell them to use the exploratory output style. So this is just like /config output style equals exploratory. You run this in Claude Code, or you can ask Claude to set this for you. And what it does is anytime Claude will make a change, it'll explain to you, hey, here's how the architecture works. Here's how this language works if you haven't used it before. Here's how this part of the code base works. It'll explain to you so that you can learn. And then there's also a learning output style which you can use, and this is for people that are not coders. And it'll explain to them, hey, here's like how this language works. Here's like, like at a very basic level, it's going to teach you how to do the thing instead of doing the thing. So it'll say, okay, in JavaScript, for example, here's how something works. I'm not going to make the change for you. I'm going to walk you through it. Step 1 is open this file and edit it in this way. Step 2 is run this command. Okay, I see you've done that. Step 3 is do this. So actually, I think like output styles and using Claude even more are a super powerful